Good morning, everyone, and a very warm welcome to the webinar on managing downtime, digital solutions for accelerating process and utility shutdown, turnaround, and outages. As we all know that the plant turnaround, whether shutting down all or part of a facility for maintenance and upgrades, is a complex and disruptive, yet essential undertaking for various companies as the businesses depend on continuous plant operation for various processes. It is critical for these activities to be well planned so as to minimize the time lag between shutdown and resumption of operations. This calls for a solution that enables plant owners to bring their facilities back in operation quickly and safely, and also offers substantial savings through the turnaround planning, execution, and post-turnaround lifecycle. Today, through this webinar, which is jointly organized by ET Infra and DESO Systems, we look forward to highlighting a concrete solution to reduce complexity and downtime to boost uptime, safety, reliability, and profitability through adoption of digital solutions. Now, ladies and gentlemen, let us open the forum by inviting our first speaker, Mr. Rajiv Agarwal, Executive Director, Technical Engineers India Limited, for his address and presentation. Mr. Agarwal would be mainly highlighting the operations and maintenance challenges in the industry and share his viewpoints on sustainable operations in this domain. Ladies and gentlemen, please use the chat box feature to ask your questions. Our speaker will answer all the questions offline through emails. Now I'll hand over to Mr. Agarwal. Over to you, sir.
Good morning, all the participants to this webinar today on challenges and solutions for accelerating utilities and process and utility shutdown, turnaround, and outages. I think it is a very apt time to have such kind of a webinar on this important subject when the industries are facing a lot of challenges with respect to profitability and sustainability. And asset management is definitely one of the very key aspects of ensuring sustainability as well as profitability to the business. So my keynote will basically have a few aspects on the key aspects of the asset reliability and asset management, followed by a few slides based on our experience in this oil and gas industry, which I represent as I am from Engineers India Limited, and we are in hydrocarbon sector, and basically supporting all the oil and gas companies in the country. Asset-intensive businesses involve significant capital investment, and the effective management of the asset is essential for the achievement of business goals. Asset management is a core function of asset-intensive businesses and responsible for management of the assets. Organizations seek to improve the value of their assets by investing in asset management efficiently in order to obtain better returns for their business. An asset management process consists of a set of key processes, which are technical and management processes to support and control the assets under management. Investing properly in asset management means to prioritize the key processes according to the strategy the business intends to pursue. The identification of which asset management key processes relate to a particular key performance indicator of a business is the first step in investigating whether the former impacts the later. This should allow the organizations to invest in the appropriate asset management key processes more assertively to improve their businesses. The Institute of Asset Management affirms that organizations are increasingly recognizing asset management as a discipline that has relevance and significant potential for improving performance of their businesses. The ISO 55000 standard not only states that asset management impacts business performance as responsible to realize value from assets, which involves balancing of cost, risk opportunities, and performance benefits. It also lists the expected benefits for businesses with the implementation and improvement of asset management. Asset management is entirely responsible for asset decisions, plans, and activities using risk-based approach related to the organizational goals. Asset management is based on 4 fundamental objectives: value, alignment, leadership, and assurance. In meeting these fundamental objectives, the AM strategy provides alignment between the AM processes and the strategic aims of the businesses. AM improves the condition of the organization assets and promotes benefits for business, such as compliance, sustainability, competitiveness, and effectiveness, among others. Asset managements aim to enable an organization to realize value from its assets. Value can take on different meanings depending on the organization's purpose and the stakeholders' expectation. Since the company I represent has a core business in hydrocarbons, and these being a very highly capital-intensive industries, the importance of asset management has grown over the years. Apart from the energy cost, the spending on maintenance can be the most significant part of the operational budgets in the refineries and the petrochemical plants. Maintenance is a fundamental component of good housekeeping practices in the industry. We must understand that a long-term cost to benefit ratio of maintenance is larger than replacement of the equipments due to high failure rates. The goal of an effective maintenance and reliability program is to provide the right maintenance on the right assets at the right time. Maintenance actions are made to reduce the failures, that means rates as well as frequency, to prolong the production uptime and reduce production loss. As the industry has high numbers of process-related accidents, maintaining planning for risk reduction is crucial for safe operation, especially for the oil and gas industry. This point is underscored by the catastrophic failure of the Union Carbide plant in Bhopal, which can be traced to the equipment failure. Maintenance management has benefited from the advent of large area in operation research called maintenance optimization. Maintenance is becoming a profit-driven business function instead of just a supportive function to the assets. The effort in improving operation uptime and enhancing assets capability and the service lifetime would improve the cost effectiveness of the process. This is specifically applicable to the oil and chemical industry, as they are highly susceptible to hazardous risks, which are detrimental to production, operation, human, and environment. Now I'll share some of the slides with you to further forge whatever I've already told you about this. The reliability of a single equipment, unmaintained equipment, is typically more depicted by a bathtub curve, which is indicates the total equipment phase in 3 phases. The first phase is basically the burn-in phase, which is the initial period of the equipment, and which is because the equipment, when it started, it has a high failure rates, and over a period of time it stabilizes, which is called the random failure phase, which is the stable operation of the equipment failure. And when the equipment is ending towards its design life, it is unmaintained. This is the last phase of the equipment operation, and it is again basically with the increasing failure rate, it is called out the wear out phase. Now, if I let us say this is typically for an unmaintained equipment. If I do a good maintenance of this, then you see that we can increase this life, the stable life of the equipment, by using predictive maintenance. I can further increase it by the first one is a time-based maintenance. The second is a predictive maintenance, where I can increase the life of the equipment with a good maintenance practices further. So this is how it shows that that we can increase the lifetime, the equipment life, the useful life of the equipment by using the correct maintenance practices. This is how typically the maintenance is categorized. One is we call the reactive maintenance, and the other is the productive, the predictive maintenance. One is the first one is reactive maintenance, which is a kind of a when the equipment has failed and it is too late to really detect, when to really take an action. The only action is that corrective action they have to take. And the second is a proactive maintenance, which includes both preventive maintenance and predictive maintenance. The preventive maintenance is basically kind of that there is already a maintenance program, periodic maintenance program, and therefore before the equipment really requires it fails, we have a maintenance program for it, and which is periodic in nature. While the predictive is something which is based on the diagnostics, and when it is a condition based, when the performance of the equipment deteriorates, the maintenance is carried out before the equipment failure. So this slide shows that the various types of maintenance strategies, how they impact the savings of the businesses. So the reactive maintenance gives you very little saving, because now only when the equipment fails you take the action. So there is a shutdown period during which you lose the production. Then the next is the preventive maintenance, which is a calendar-based maintenance. Here we have a where, because now I'm spending more on the maintenance, so still my profits are not so large. And the second is proactive and the predictive maintenance, where the saving, there is a substantial increase in the savings, and I'm using the online diagnostics to basically to decide when the maintenance of the equipment is required, and then only I spend on the maintenance of the equipment. See, these are some of the case studies that we have performed during last. These are some of the recent ones, because we have a dedicated division for handling these asset reliabilities and health inspections of the various equipments. So, this is a case study when one of the owners in the oil and gas sector itself, these tanks, they were storing cryogenic liquids, hydrocarbons, and there was a failure that was noticed by the operational operators during the operation of the plant. But because there was no maintenance schedule for this, so it went, nobody really took action and kept waiting for it, and which basically resulted in a catastrophic failure of this tank, such that there was no possibility of maintaining that tank, and the tank had to be replaced. Therefore, there was a replacement cost of about 150 crores, which owner has to bear. Along with, there was a it was a very complicated tank, and it took 3 years to build the tank again. So the total loss that we estimate is about 650 to 700 crores that owner had to accrue because of the incorrect maintenance practices. This is another case study where a crude pipeline, which was an offshore pipeline, was running since years without any maintenance plan. One fine day, the leakage was observed in the pipeline. This incident, because this was handling crude, so the crude actually went into the sea, and there was a lot of environmental issues. Although the stoppage was not very long, it was, I think, only a few days only. The pipeline could be maintained, but it has a lot of other impacts on environment and aquatic systems. See, this is also one of the example of the recent case which we have done, where it was a mounted bullet in one of the our clients. And this mounted bullets, it has gone through the periodical inspection with using the conventional techniques, and the defect that was in the bullet could not be traced because of the conventional techniques used. And when the bullet was again taken into the surveys, the leakage was observed. And since this was very important for the client, and otherwise they had to shut down the whole plant itself, so they involved EIL, and EIL, using its latest NDT techniques and innovative repair techniques, guided the repair of the bullet. And this was a first case when an internal repair of the mounted bullet was carried out. and it was successfully done, and even with the approval of PESO. And this shows the effective maintenance plan that the company should pursue. This slide only shows that what are the kind of various models of strategies that various companies can adopt. Normally, what they adopt is a mix of all these two. So corrective maintenance is typically something which we will try to avoid. But sometimes if the equipments are not, let us say, equipped with diagnostic and all, I mean, this is what probably we'll have to follow. So it is corrective maintenance, time-based maintenance. Then we have risk-based maintenance, condition-based maintenance, and opportunist maintenance. Opportunist maintenance is something which is coming out from the condition-based maintenance, that when the diagnostic shows that the equipment is likely to fail, then whenever you get a shutdown of the plant, not because of this reason, but because of some other reasons, then you can utilize that opportunity to maintain even this equipment, and therefore their total the total shutdown time required is much less, and it basically enhances your profitability. So these are the various reasons, or the factors which guide the maintenance strategy which can be adopted by the various companies: investment cost, safety hazards, environmental constraints, failure and maintenance costs, plant reliability, manpower allocation. So depending upon the various factors that the company may have to look into while charting out their maintenance strategies. See, this slide basically shows you that how these correct maintenance strategies help you save the money as well as manpower. Ultimately, it is the operating cost. So if we apply the current industry practice is the traditional distribution, where we carry out, let us say, about this is typically a slide for the oil and gas industry. About 65% is preventive maintenance, 30% is corrective maintenance, and predictive maintenance is very less, which is only 5%. So if we move to the new practices, where let us say we can have about 40% predictive maintenance and 20% is preventive maintenance, corrective maintenance reduces to a large extent by only 10%. So overall, there is a reduction of about 30% in the maintenance requirements. The team required for the maintenance is also reduced by about 25% while we adopt the new practices, because it is being helped by the digitalization, the online diagnostics. And definitely then the last point is that the cost saving, that in terms of the operating cost and the maintenance cost, what overall cost saving is expected to be 40%. EIL has been serving the oil and gas industry since last 50 years. And therefore, EIL being a world-class consultancy services in oil and gas sector, is involved in almost all the upstream as well as the downstream segment of oil and gas sectors. EIL has executed many prestigious and critical projects and supported in nation building. Given the impetus on increasing requirements of asset management, EIL has a dedicated division to provide these services to the industry for asset management to our esteemed clients. Being a design and engineering consultancy, EIL possesses all the know-how of the processes, equipment and maintenance requirements of the oil and gas sector, and providing dedicated services in this field. So finally, this is the way ahead for the industry, that maintenance is in this era faces the challenges of utilizing the latest technologies and concepts in the form of smart systems that predicts failures, makes a diagnosis, and triggers maintenance. The architectural design and the conceptual framework for smart maintenance decision support system that is based on incorporated big data analytics can be utilized for asset management. More effective technology systems and knowledge base are needed to transform the fail and fix strategy that is currently prevailing in the industry to predict and prevent strategy that we have to adopt to be more, to make our business operations more profitable, more sustainable. So with that, I thank you all, and I think this will be carried forward by my fellow speakers, who will basically give that how the digitalization can help to achieve all these objectives. Thank you. Thanks a lot.
Thank you, Mr. Agarwal, for sparing your time for this event and for sharing all the important information with us today. With this, ladies and gentlemen, we'll now move on to our next presentation. For the same, I'm pleased to invite Mr. Vinny Jaiswal, Deputy Chief Executive Officer, Center of Excellence, Vedanta Limited. Let us now hear from Mr. Jaiswal on the turnaround business challenges and the need for digital turnaround. Welcome, Mr. Jaiswal. Over to you.
Good afternoon, everyone. Welcome to the webinar. And I'm sure you had a great session with Mr. Rajiv. What I will do is I will share some of my experiences, some of my thoughts. And before I go there, a little bit about myself. I lead the Center of Excellence at Vedanta. There are 6 different functions: asset optimization, the topic which we are covering today, quality, R&D, innovation, IT, and digital. So tell me, will any one of us like to sit in an aircraft and suddenly it stops midway, right? None of us will like to do that. And the reason none of us will like to do that is because we don't want to die. So if we treat all our assets, right, regardless of whatever assets we are in, if we are in power plant, if we are in manufacturing of aluminum, zinc, or any other thing, right, will not, if we treat them like an aircraft engine, it will not stop midway. Now, let me explain you the analogy of what exactly is this aircraft engine maintenance secret, right? The way they do it, right, they follow a very stringent process. Before even the aircraft comes, they are aware what needs to be done. When the aircraft is on the ground for maintenance, there are multiple people working on it, and there are multiple staffs, and they track each and every one of them. And post facto, they do analysis, right? And there is a continuous process, and it's continuously getting improved. So if we start treating our assets the same way we treat an aircraft engine, it will behave the same way. There are 4 different criteria for success for a great turnaround, right? One is it should be a zero fatality thing happening there. It should be completely safe, right? Whatever we do, if we are able to understand the entire process, figure out any issues which can be created and handle it much ahead, that would be making sure right PPs are there, right trained people are there. So this is one of the most important success criteria for a great turnaround. Then is the schedule overrun. Any delay is a cost to the company. When I say cost to the company, if let's assume an capital overhauling is planned for 45 days, and it took another 5 days because of the process, right? You lost opportunity for production for 5 days. So it's going to impact the company overall revenue. Then is cost overrun. Sometime either you ask for more parts which is not needed and which will be just sitting in inventory, or you don't plan it right and you are not having right parts and you buy more expensive ones during the turnaround. This can be a problem. Finally, one of the most important aspect of it, right, is the great quality of the work, right? That we know who is going to do what, how exactly it is done, and post facto, understanding the entire factor, making sure that the assets will run the way it should be run. Success boils down to these important factors, right? How is the planning done? How is the execution done? And post execution, how is the analysis done on the data, right? Let me cover each one of them. On the planning side of it, right? If we do a more granular planning, when I say granular planning, it is like more of a scientific approach where entire details are there, what all jobs are taken. I will give an example. We are doing, there is an upcoming capital overhauling, and there is a we have made sure the right experts are there, right manpower which is needed is there, and everything which is needed across in terms of a successful, we have planned it very, very well. Manpower and procurement scheduling, right? So, and the aspect of this is that anything which is needed in the entire process are available to handle it. Finally, online approvals, right? There are a lot of things which he needs. Certainly, you will see any of these exercise. Uh, there are bureaucracies, right? Do you have budget for this? You need something extra. If the visibility is complete, pre-work can be done on time and very, very well orchestrated. During the execution cycle of it, right? If somebody captures the progress, right? Let's assume a thing was supposed to be done, a welding was supposed to be done, right? If it is done and somebody captures it on the mobile, uploads it, either it can be just approved, or if it needs a two-level verification, somebody else can audit it and do that, right? If it's a real-time process, the entire progress can be captured at a higher level. Inspection evidence, right? So let's assume I did the work and somebody else came for inspection, right? That person can timestamp it, as well as it will also person stamp that who exactly has done. Finally, the entire process which is orchestrated very well during the process, because these are not 1-2 days job. Generally, these kind of overhauling takes about 15, 20, 30, 2 months, right? So if it is done in that way, if you want to see the progress, right, in the S curve, it will be very, very dynamic, right? What are the critical paths? Where is the progress? I'm sure none of these goes like everything as planned. But if there is a change, right? If somebody gets sick or some kind of a part broke, right? How exactly that can be mitigated very clearly, and we have the entire visibility. That dynamic decision making can be done through these kind of tools. Now, post facto, right? What we really want out of this data, the entire thing which was done during the process of execution, if we capture the data right, it will move the organization from a person who has done this in maybe 2-3 years back and again wants you would need this. Rather, it is more of an intelligence space, right? Next time, the first one, the left side or the planning side, will be much better because you know what exactly was needed, what exactly went wrong, right? So this is the most important aspect whenever I look at any such tool. Also, it will give us a trend analysis, right? Making sure we understand the overall aspect of what is the dependency, what is the impact, and how exactly this can be seen. And finally, it's a single source of truth. I say this, right? This is not in an Excel sheet that somebody entered and somebody modified, or any such tools. If it is done in a scientific way, it can be handled that way. This is my final slide, and let me talk about what are we doing at Vedanta. Right? We have embarked towards the journey, and we have started looking through a digital angle to handle all these. We have picked a couple of tools at different businesses, but our overall objective is for a real-time data management. When I say real-time data management, we want to know exactly what's happening at the site. Are we going to meet the timeline, right? I will give example, right? If in a power plant, right? If we have to do an overhauling, this is a very, very critical aspect. We need to know exactly what's happening, where exactly we are, and when exactly the plant will be back, right? So when I talk about any such activity, right, uh, in terms of asset, we have started treating it like an aircraft engine everywhere I go. Right now, I am currently traveling, but wherever I go, one of the things which I see everyone talking about is how can we make our assets more reliable and more available. So availability and reliability can be increased if we really go through this dot process of having treating all the assets like an aircraft engine, and it will treat you the same way back for yourself. So that's all from my side. Hopefully, it covered the areas which you are looking forward to. But what I will say is, whatever do it with passion and make sure you treat your assets like an aircraft engine so it doesn't fail in between. Thank you. Thanks a lot.
Thank you very much, Mr. Jaiswal, for sharing your thoughts and valuable insights with us today. Indeed, it was full of learnings and takeaways. Now let us proceed further to our last presentation for the day. And for the same, I would like to invite Mr. Mansoor Sheikh, Senior Technical and Solution Manager, DESO Systems, to highlight on how 3DS digital turnaround management solutions can address the turnaround challenges faced by the industry. Ladies and gentlemen, just a reminder to ask your questions using the chat box feature. Now I'll hand over to Mr. Sheikh. Over to you, sir.
Good afternoon, everyone. Thanks for joining today's webinar. And thanks, Mr. Rajiv Agrawal, and thanks, Vinay Jaiswal, for basically pointing out the issues and the technical, the industry challenges and how we can basically overcome these challenges. So today, I'm going to talk mainly from a technical aspect, how we can basically help you with your turnaround management solutions. Our company, DESO Systems, it's a purpose-driven company with 20,000 passionate people in over 140 countries. And we offer solutions for 11 industries. And with this 11 industry, infrastructure, energy, and materials is one of the industry where we basically provide these solutions to our customers. If we talk about this particular energy industry, it spans from mining, oil and gas, refinery, chemicals, process industries, and power as well. And we basically have solutions for each and every different, let's say, from the project capital facility standpoints to operations and vertical solutions as well. So today we are going to see one of those solutions, what we offer. So as you know, basically coming from the same industry, one of the some of the key challenges of turnaround management is obviously extensive coordination between multiple stakeholders. The contractor productivity is low because of various reasons, skill shortages, and so forth. And we have unaccounted maintenance requirement, which is like you come on particular day and you see that, hey, this has not been accounted for, and obviously safety and compliance reasons. And obviously that translates to your loss of production. And that is what we want to address here. How can we basically minimize the loss of production? Now, very quickly, we know that the turnaround cycle is 4 to 5 years cycle, operation cycles, and then 1 to 2 months of your implementation or the maintenance or shutdown, what we call shutdown, outages, maintenance cycle here. Now, what we would like to basically help the industry is basically extending that particular cycle from 4 years to 4.5 years or 5 years as well. And also to shorten the duration or make sure that your turnaround is as planned to maybe 4 weeks, 6 weeks, whatever it is. We don't want it to be extended further. So what we term this as STO, which is shutdown, turnaround, and outages excellence. So the key KPIs for these in this particular business is obviously safety. You look at the quality. When I say safety, you need 0 injuries and so forth. Quality is obviously you have so many information, so many systems in these ERP systems, cost management systems, contracting systems, and so forth. And we want to have a quality type of documentation as well as quality work on site. The schedule should be on track, on time. That's the key to actually make sure that we start and finish on time. The obviously cost is one of the major factors. We want to make it on budget. And as previous speaker mentioned, knowledge, how do we basically try to capture our knowledge for the next generation to come, or for the young engineers and so forth. We call this as XTO excellence, and we can achieve that using a 3D experience platform, what DESO Systems offer. Now, what is 3D Experience Platform? Now, this is a massive platform which basically help you with so many different solutions and tools and collaboration tools and so forth. Just to give you a glimpse of what the 3D Experience Platform is, it has got on the left-hand side, it has got multi-dimensional modeling, which means you can model a three-dimensional, and as well as with the timing, as the fourth dimension, and we can capture the knowledge, the lessons learned, and all of those information. We are basically started with the project lifecycle management, so you can manage the plant lifecycle of the assets from its inception to decommissioning. So we can manage the full lifecycle of your assets, all the different types of data in this particular world. How do you basically try and understand and derive what information you need? How can you move your facility from a reactive type of approach to your predictive and proactive type of approach by analyzing all your data? And obviously with virtual training, realistic simulation, and virtual maintenance, your employees can actually learn of the unknown conditions. How can you basically teach them or even train them or even help them to work in hazardous conditions? And obviously with all the different applications today, we can interface. The 3D Experience Platform have a capability to interface and derive information from your various systems of records. Now, we have we basically told you that we need to achieve that excellence here, and obviously trying to achieve that excellence in all the different phases of your turnaround, and the key KPIs being safety, quality, schedule, and cost, right? Those are the key KPIs. Now, how can we help and how can the technology bring in? The Dassault Systems turnaround solutions has a lot to offer in this particular business. I can't really go into much details, but to give you a very high level 30,000 feet overview, we have scope and work package based management. We can do scheduling and planning within the 3D Experience Platform. All the documents can be managed. You could manage your contractors and all the dealings with your contracts, collaboration within your very internal collaboration, as well as your collaboration with various different stakeholders. How do you basically transmit information between contractors, subcontractors, and so forth? Transmitter and bid management is the answer for that. We could interface with your existing EAM solutions or even project management solutions. You could track material tracking with your material tracking solutions, knowledge capture, which is basically trying to capture all the various information and so forth for the next turnaround and improve on the next turnaround. Dashboarding and reporting capabilities, alerts and notification, obviously helping people to act and on time so that it's not overlooked, all the tasks are not overlooked. And obviously we have a list of all the libraries. That means, for example, job package library is a list of all the activities that needs to be conducted on a specific piece of equipment. Say, let's say columns, though, you already have a predefined activities that needs to be managed in particular column, and that can also be customized and added to your needs. And obviously joints and isolation management, which I'll be showing as a sample or example demo in a few minutes. Now, just to give you an overview, this is just to give you a high level, right? So this basically, all of these different components of the solutions come together to actually help you and give you a full-fledged solution to manage your shutdown or outages and help your crew members to act in a proper manner, in a timely manner, and so forth. Let's move on straight away into some examples rather than showcasing many of the slides here. Now, I want to show you one of the examples where this is on the left-hand side. What you're seeing is a plan, and on the right-hand side, you're seeing is a 3D model. When you select any of those assets, it can basically simulate and show you exactly how things need to be done on site. This is a good thing for your training. And also, it is also good for your planning. For instance, if you wanted to bring a huge 500-ton crane and a limited confined space, how do you plan? You can use your simulation and planning tools to actually simulate and train well ahead of doing it on site. So that's one of the examples. And the second example is what I wanted to also touch base is a real scenario on the site. Most of you may know we have isolation barrier. Basically, whenever you want to clean up a particular column or vessel or anything, or do any of those maintenance activity, you first need to isolate all of those connecting pipes and the inlets and the outlets so that everything is clear from hazardous materials. And then you basically do the maintenance activities such as flushing and so forth. Here, what you're seeing is a PNID. Now, in this particular PNID, you have got this particular vessel here, and you've got all the different lines, pipelines, and you've got 1, 2, 3, 4 walls. Obviously, this is your isolation barrier or isolation loop or isolation circuit you could imagine. Now, if you have a 3D model, it particularly looks like this. Mapping each and every wall to your 3D model. And obviously, what you need to do is to conduct any particular activity on site, you basically need to action, which means you need to close this wall, close this wall, close the third wall and fourth wall, and then you're good to go with your maintenance activity for your shutdown or outages, right? So I'm going to show this particular example in our solution so that you have a good understanding how our system works. Now, what you're seeing on the screen is various different turnaround projects. On the left-hand side, what you're seeing is the solution definitions, which I've explained to you previously. We are looking at the isolation barrier management module here. Now, I'm going to create a new isolation barrier, right? This is an example here. Now, I'm going to give a name of IS100 THT007. All right, this is my isolation loop, isolation circuit 007. And when I click what are the line numbers, I can just select the line numbers because all of these line numbers are already in our systems, right? So we could fetch this information from your PNID drawings, your 3D CAD models, and so forth. And you can basically select all of those in the system. And after that, you basically selected the line, you're now selecting your equipment, and then you're good to go. You've selected line, you've selected equipment, and you have already named your isolation loop. Now you've got 007, which is already created. And if I expand that, you will see that this particular isolation loop has got all the different line numbers that make that particular loop. Now, I need to add the walls, which needs to be actioned, right? For example, which needs to be closed or opened and so forth. So I'm going to add the wall now for those isolation loop. Again, as I said, we are retrieving the wall information and all of those different information from your source drawing, whatever source you have got. We could also bring it in, such as PNID is again your all of those 3D CAD models. Now, I've added 4 walls as shown in my previous example. So now I'm going to start. Now, this particular isolation activity has not started on site. Therefore, what I'm going to do is I'm going to make sure that, first of all, I need to assign the sequence of it, because you can't basically go ahead and close everything, right? Because it may be hazardous. So initially, I'm going to assign which sequence, which action need to be done in what sequence. So I've assigned the sequence 1, 2, 3. And then on each wall, I'm defining an action, which is whether it needs to be closed, it needs to be opened. Initially, for example, here I need to close all the walls and in a sequence of 0, 1, 2, 3. Now, what is going to happen is this is a planner's screen, what you're looking at. Now, the planner will basically say, hey, all right, it's time to start the isolation, and I'm selecting the isolation number. And he is going to start this activity from his desktop. As soon as he starts the activity from his desktop, a new field activity has been created, which is ISOT 0081. That has been created, which means, and you can see a red cross there on the left-hand side, which means it has not been started. This particular activity is going to be carried by your field personnel. he will straight away see on his device, on his iPad or his mobile device or whatever it is, and he sees that 0081 is assigned to a field personnel. He'll look at the activity information, and once he completes the activity, he is going to move from to-do state to basically complete state. He can obviously add the images that he has taken on site and so forth. Once he's done with this particular activity, it is completed. Now, instantly, as soon as this is completed, the planner, if he refreshes on his screen, he will see that this particular activity is green and the next activity has already been initialized, which means it's red. So that means the next person can actually work on the second activity. So here we consider all these safe, real practical scenario where one particular person should not basically go ahead and do before a specific job has been completed. So this is a sort of one particular example that I wanted to show you guys to just give you some sort of an idea how our system can basically address each and every use cases for your maintenance, shutdown, and turnaround maintenance activities for your process, facilities. So that concludes my sort of a pitch here, and try to show you how we can help you with our solution. Please feel free to basically get in touch with us, and you can always email us at in.mkt.value-engagement@3ds.com. And we are happy to help you. We can basically sit with you and try to understand your problems and your pain points and your KPIs, and basically we have a solution for you guys.
Thank you, Mr. Sheikh, for your informative presentation. I'm sure this is very helpful for our participants serving the industry. So with this, we come to the end of our webinar. Thank you to all the speakers for sparing your valuable time for this event and sharing some very interesting and valid points. Thank you to the audience for your participation. Keep following etinfra.com for all the latest updates and insightful content in the infrastructure sector. Once again, thank you to all of you. Take good care of yourselves and your loved ones. Stay safe.